Good afternoon, friends. My name is Samir. I'm the Chief Marketing Officer at LandT Technology Services. This is our second time over here. Hopefully many of you recall us from last time. It was our first time over here, and we were learning how to crawl before we walk, but I think that we are ready to run. Today I have two of my colleagues over here. I have Mahendra Joshi, who is Head of Solution and Technology based out of North America. I have Prabhakar Shetty, who heads our practice in digital manufacturing. He's over here. With that, without taking any more time, I'll hand it over to Mahendra.
Thanks, Samir, and good afternoon, everybody. Just wanted to give you probably an overview of what we are doing, especially in the digital space. What is the kind of background, what kind of projects that we are doing in that particular area, where our focus is. So, as a LandT Technology Services, as a snapshot, we are about 10,000 engineers strong now, and having more than 200 global customers. Probably one of the major point that I would like to bring out, where we take pride, is the number of patents that we have generated, co-authored, while working on some of our customers' projects. These patents obviously belong to our customers. Some of them is our own investment, and we have come up with some of our own patents, which we are in the process of monetizing. The another important point is probably the 90% business is the repeat business for us. Goes to show the customer satisfaction and the quality of the work that we have been doing. Some of the very leading or technically complex projects that we are associated with, I would say building one of the smart campus coming up in Israel for one of the semiconductor giants, where we are playing a leading role in terms of implementing some of the digital solutions there. Or we are working in the area of network of grids and microgrids, etc., in that particular space. And also working on the electric aircraft, quite a few projects going on in the electric aircraft space. But in terms of the services and the areas of engagement that we have with number of customers, we really play a role with right from product design development, whether it is at R&D stage, right from capturing the VOC to getting down to the product design architecture, both from embedded perspective, electrical, electronics, mechanical architecture, doing the product launch, certification, manufacturing transfer, playing a role into the life cycle management, whether it is value engineering project or managing the component obsolescence, etc. Then getting into the manufacturing support activities. How do you get into the automation? How do you improve the efficiencies on the shop floor? How do you reduce the waste in the area of manufacturing? So these are some of the areas where we work on the project. And we have the process engineering service offerings, where we work in the space of plant engineering. Working on both brownfield as well as greenfield projects, supporting a number of customers. So really speaking, it is right from new product introduction, managing the product life cycle, working on the quality space, manufacturing space. So that is the kind of gamut of services or the nature of projects that we have across different verticals. We have not mentioned about the verticals here, but quickly to give the glance, probably the transportation, within transportation, aerospace, automotive, off-highway vehicles, railways. We are into industrial products, healthcare, life sciences, medical diagnostic products, telecom and high-tech. So across entire verticals that we have the presence, and we cross-leverage the ideas and the technologies that we learn while working from customers from different industries. Coming to the topic of digital, particularly, I would say one of the major or the unique value that we bring to the table from our customers' perspective, and this is something I have learned from our customers when I interacted with them. Probably the unique part is right at the bringing in the capabilities to work at the sensor level. Let's take, for example, we are looking at making the smart manufacturing or the smart machines, etc. How do you capture certain parameters? What kind of sensors you will use? How do you extract the data from the PLCs or the controllers, aggregate that data? So right from sensors, getting into the connectivity, whether it is the local industrial protocols or taking the data to the cloud, the security aspect of how do you maintain the security, how do you retain the security part, how do you address the security. So the entire chain is something that we are able to address. And then after taking the data to the cloud, doing the analytics on that data, doing the data analytics part, right from not just the data cleaning or correlation kind of activities, but building the different algorithms, predictive in nature or prescriptive in nature, and then making sense out of that data. That is something which we are doing. Number of applications development, etc., that goes associated with it. Some of the areas where I would like to kind of showcase different projects that we have worked on in this particular space. As you can see, the diverse industry applications, like we work with one of a windmill manufacturer in Europe, one of the leading manufacturers, and collecting the data from various windmills and sensors. As an extension of that, we are building our own framework, which is suitable for microgrid kind of applications. We are specifically working on algorithms that are into the demand forecasting and supply forecasting. So microgrid is one of the area where we are doing our own investment in terms of building different algorithms. We have gone into another example, which is the welding machines, where it is some of the features that we have implemented. We work with 3 leading welding equipment manufacturers in the world today. And some of the solutions that we have come up with is, like, it tells the operator the quality of the weld that the operator has come up with. And you can actually give the welding pattern score, and you can keep on improvising. But at the same time, looking at the nature of the joint, the nature of the material and other things, the welding machine sets its own different parameters. So that is the kind of solution we have implemented. For machine health monitoring that you see at the bottom left corner, it's something where we are doing both vibration analysis as well as the acoustic analysis on a gearbox to come up with the kind of predictive failure or the predictive in nature algorithms related to the gearbox. The elevator performance, one of the leading manufacturer in North America, where we are working on the elevator performance monitoring solution. We have come up with different solutions that can reduce the technician's time when he makes a visit to attend a particular issue or a particular installation. How do you cut down the time of technician he spends, and then coming up with solutions in that space. So these are the kind of variety of projects that we have done. Involves IoT right from sensor level, getting the data from additional external sensors, getting the data from machine controllers, aggregating that together, and then running the analytics on top of that to derive the business value. We kept it in line with the theme of this particular conference in terms of smart machines and smart factories and smart cities, and wanted to share some of our solutions that we have come up with and some of the projects that we have worked on in that particular space. We already have the Ubiquitous or the Wages and IBEMs, some of our own IPs and solutions in place. The recent addition to all this line is I know analytics framework that we have introduced recently. This is basically it is more of a framework that gets customized to build the different algorithms for a particular industry for a specific application. It gives you APIs into multiple data analytics tools. It has some of the pre-built libraries of algorithms that we have come up with that comes as a part of it. It has certain visualization modules and reporting tools as a standard built-in module. So it is a framework by itself that we have come up with. We have already done some of the implementation using this framework, and now it has been launched in a kind of formal manner. But apart from that, we have done multiple, I would say, the implementations using some of our other solutions that are already there in the market. Some of the things I talked about the smart belt, but rotating machine monitoring. This is something where we have invested and created the lab to come up with the algorithm. If you take motor or any rotating machine, that becomes the basic component of any of the machines that you have. And what we have invested in is creating different types of faults on motors and then building the algorithms and validating the correctness of those algorithms from predictive nature perspective. How well we are able to predict the different faults. So, and using that, we have done quite a few projects with number of our customers. One of the customers, I would say a brewery in North America, they have a very critical pump where the failure of that pump can result into millions of dollars of wastage. And we are building a solution on top of that by monitoring, by putting additional sensors and building the algorithms to predict the failure of the particular critical pump set. So those kind of projects we are doing. Or we are doing number of projects in different industries to monitor and predict the OEE in real time. The machine OEE, so to improve the machine uptime, downtime, the effectiveness. So those are some of the areas where we are working with number of our customers. Augmented reality is something another I would like to talk about. Augmented reality, virtual reality based number of projects that we are doing. Right from operator training or from better investigation perspective, the field failure analysis, etc. So these are the kind of things we are working on. Getting a little more into the detail of the analytics platform, rather than getting more into the technology aspect of it, probably some of the areas where we have built the solutions. I talked about manufacturing and industrial automation, the doctors or the healthcare and the medicine part of it. That is where we have done number of projects, some of them in the area of orthopedics, where it is more for example, one project we are doing using the artificial intelligence is when you go to the, when you are doing, let's say, a kneecap, and you need to extract the bone portion from the X-ray image. It's a lot of manual work. So we are building the automated knee extraction modules, which keeps on learning, etc. So those are some of the projects that we are doing in that space. Or some of the projects we are doing is really assisting the doctors in guiding in towards the diagnostic by taking the different physiological parameters and then correlating those and then coming up with the better diagnostic tool. That is one area. Like one example I can give is we have a good expertise in the area of ultrasound as well as X-ray. One project that we are working on currently is the fusion of ultrasound image and the X-ray image for the kidney stone removal, so that you can improve the accuracy of stone detection rather than going it by trial and error. So those are the kind of projects we are working on. I covered this, I will not get into detail. This is one of the other area completely different. How do you improve the documentation? This is the project we are working with a company of major in oil and gas sector, using the NLP based algorithms and queries you have tons and tons of documentation. How do you improvise? How do you do the effective query and then extract the relevant data? So I think number of them which are, this is something in the manufacturing space where we are, this is actually a solid example where we have delivered millions of dollars of savings in this particular place, where we are doing the factory simulation or the robot line simulation before you actually go and install that, and then simulating it. So this is something on the wages side where we are working on the, we have come up with the application that is used for monitoring the various energy components, water, gas, electricity, etc. And then we come up with the ways to do the energy conservation. Number of areas in smart city, the IBEMS is basically the various smart building or the building automation related component. This is the, again, our proprietary application that sits on top of various building automation components in a commercial or residential building, and then correlates the information for better energy management. This is some of the more details that we get into right at the communication level, etc. But this is something again we are doing with one of the airports from the facility management perspective. So 3 different use cases that we have created using our own IoT platform, and then have deployed. They are under demo evaluation at this stage, getting into the area of dustbin management or waste bin management, and the number of seat occupancy, etc. So how do you deploy IoT for airport kind of buildings? I think I'll stop there. Had to rush through, but definitely.
We have time for a couple of questions if you want to.
Yeah. Yeah, go ahead.
Yeah, I know it's not a technical question, but I'm just fascinated. You're doing AI with medical and interacting with doctors. Having done quite a bit of work with doctors myself, I found them to be very jealous of their purview. And what has been their reaction to your coming in and trying to assist them in surgeries like kidney stone, knees, etc.? How have they received it, in other words?
First and foremost, I would say.
Repeat the question quickly, please.
Yeah, the question, as I understand, what is the reaction from the medical fraternity about AI getting used in the diagnostics in general, if I say so? I would say the response that we have received is very encouraging. We have the relationship with number of doctors and pathological institutes within India and North America, with whom we keep working on, I would say, the projects of this nature. I wouldn't say any project has reached a level where we can subject it to, let's say, the accuracy certification like FDA or anything like that. It has more remained at a trial level, and we keep on improving the way we work, and that is where we found the medical fraternity is quite, medical community is open. They bring the domain knowledge and the challenges that they face, whereas we bring in the engineering angle to it. I talked about one of the surgical example. I have similar examples in the area of pathology domain, where we are doing the automatic detection of cancerous cells, for example, and coming up with the exact count of that. So we are building multiple different algorithms in that domain to come up with, that is where we are deploying AI techniques in medical healthcare.
Thank you.
Thank you.
Any other questions? Yes, sir.
I can be last. This is regarding AI, the new AI product is AI KNO. has that been applied in the industrial sector? Is there a use case? I know it's a new product, it may not have been applied yet, but is there a use case you could talk about in the industrial space, an application example?
Industrial space we are working on, particularly in the area of predictive maintenance of some of the machines. One example I can take, very close to the actual case that we are working on. This is a very high volume plastic injection molding component that is getting manufactured, and the particular customer has, I would say, close to, on a shop floor of roughly about 50 different injection molding machines. And what we are doing is getting the parameter. Okay, before that, they are at a level of 87% first pass yield today across the shop floor, and they want to go to 93%. At that level, every percentage point is a Herculean task from the improvement perspective. And what we are doing is collecting the various parameters in the entire injection molding process, acquiring that data, analyzing that data, and then putting it, running the algorithms on that to kind of give the forewarning to stop. Let's say, for example, the granules itself are not preheated to the required temperature. Then we are building the algorithms to give the alert saying that stop the process on this particular machine, the temperature has not reached, etc., etc. I picked a very simple case, but in such kind of case, we are working right from acquiring the data with a required resolution and accuracy, and then building these algorithms on top of that. So that is the kind of example that we are currently working on.
Thank you.
Good, thank you very much. We're out of time now. So.
Mhm.
Thank you, gentlemen.